Okay, welcome back everyone. In the previous video, we were working out the uniform payment problem where we were trying to find the amount of annuity you'll have to pay each year to balance out this $1,000 loan. And earlier we looked at it by using the formula, the one that I showed here. In this video, we're looking at how to solve this problem by laying it out in a table where I have my individual cash flows in one column, the discount factor in the next column, and the discounted cash flows in the last column. Now, once you add all of these cash flows, once you take the sum from of the discounted cash flows from year 0 to year 3, you're going to get the net present worth of all the cash flows. So in order to balance these negative cash flows with this positive $1,000 cash flow, the net present worth has to be equal to 0, which means that by incorporating time value of money, the it's basically a balancing problem. And I'm going to set this objective cell, the NPW, to 0 by varying the annuity, the amount that I'll be paying each year. And my solution comes out to be 402.11 which is the same as the one we calculated using the formula. All right, so the cash flows for the uniform payments. I want to make a similar table, but this time for the gradient payments right here. So if we look at the structure of the gradient payments here, I'll set a new decision variable. Let's say the my initial guess for the gradient payment is $100, and of course I need to switch this to my new reference, make that an absolute value, and drag it down. And this for this problem, I'll be going from year 0 to year 4. So I'll have to drag this down, add another row, add another row, and okay, so at year 1 there is no cash flow. At year 2 we have 1 times g, so it's gonna be, I can write the formula n minus 1, the year minus 1, times the gradient amount, and just drag that down. So yeah, 200, 300. Alright, so let me just fix this formatting real quick. Okay, I just want decimals here. General, yeah, that should be, yeah, this is good enough. Okay, or percentage, just to keep it consistent. So the discount factor, we know all the discount factors. At year 4, the discount factor is going to be 68%. And let me just drag this down as well. Now I have to, in order to find the NPW, I have to take the sum for all over the entire 4 years instead of 3 years. Okay, so we have our table set up. Now the thing that I really like about this method is that you, you have a column for your cash flow, so you can see your cash flows, and you have another column that shows you the discount factor for that particular year. So there's this level of detail gives me shows me precisely what is happening in the problem. And if I just know the basic principle that in order to solve this problem, the negative cash flows have to balance the positive cash flows. The negative discounted cash flows have to balance the positive discounted cash flows. That's how I'm gonna work out the amount that will be required to pay each year. So once again, I'll go back to solver. Okay, D21, this objective cell, let's highlight that. Set that to value of 0 by changing variable G this time. And lo and behold, we have the value of G required, and we have the cash flow in each year, and we have the discounted cash flow, and the NPW almost comes out to be 0. If I hit it another time, so this is as accurate of a solution you're gonna obtain, which is, and this resolution is satisfactory. I can increase the constraint precision, I can increase the number of iterations if I'm looking for a finer solution. All right. And one last thing before I wrap up this video. In Excel, if you go under the formulas tab, there's an entire list of accounting and finance functions that you are more than welcome to use. So, for example, this FV future value function, it's just the F equals P times 1 plus I raised to power n. Like, this formula is hard coded. Same is the case with NPV. You can select an array and you can select an entire array, specify the interest rate, and it's going to find the NPV for you. PV, given a future value and an interest rate, you can calculate the present value. So if you find the financial formulas more helpful, then you're more than welcome to use them. However, I like to stick with this this tabular form where I have everything laid out in front of me, just because it gives me more control. All right, thank you guys.